Hi everyone, in this lecture we'll cover part 2 of our discussion on perception in visualization. We will continue from where we left off. We want to go over the building blocks of data visualization. We compared pre-attentive processes against the attentive processes in the previous lecture. We learned that pre-attentive processing is faster and is not using any conscious effort, whereas the attentive processing is a slow, deliberate, and focused processing of a visualization. Here we want to further understand the role of pre-attentive attributes in data visualization. In particular, we'll go into the details of color and size, two very important and strong pre-attentive attributes that are highly effective in data visualization. Later in the lecture, we learned the two thinking systems, namely System 1 and System 2, which respectively produce fast and slow thinking to make sense of the world. These two systems correspond to the pre-attentive and attentive processing of visual data. We are born with an enhanced visual path to cognition. Vision is our dominant and primary sense. About 70% of all the sensory receptors in the body are in the eyes, and 40% of the cerebral cortex is involved with processing visual information and making sense of what we are seeing. Visual perception is closely connected to understanding, and as a matter of fact, this is reflected in our language when we say things like, "I see what you're talking about," "sketch out the idea," or "seeing is believing." Broadly speaking, we have long-term memory and short-term or working memory. The difference between these two is in their duration and in their capacity. Long-term memory is important because it is the core aspect of our learning that allows us to have a wide range of skills and behaviors that are vital for our survival. For example, with our long-term memory, we remember how to drive a car, ride a bicycle, we remember our first day at school, and many other things. While long-term memory has an unlimited capacity that lasts for years, short-term or working memory is relatively brief and limited to a small number of chunks of information. For example, short-term memory can be used to remember a phone number that has just been recited. Data visualization allows us to consolidate complex statistics and big volumes of data so that we can process more data simultaneously. With proper visualization, we absorb more information faster and with less effort. This is because data visualization reduces conscious processing, and at the same time, it takes advantage of pre-attentive processing, and therefore it expands the working memory. Also, we should remember that the main purpose of data visualization is to aid in good decision making. As we stated before, pre-attentive attributes are visual features that we notice without using conscious effort. They're basically the building blocks of data visualization. We use these visual features to make it easier for a user to understand what is presented and save them from consciously processing and going over all the data. Examples of these visual features or properties, as we showed in the previous lecture, include orientation, length, width, size, enclosure, added marks, curvature, shape, color value, color hue, which is the name of the color, position, and spatial grouping of the data. And of course, there are more of these visual features or pre-attentive attributes that enable us to perceive the data. For example, we have texture, we have orderliness of symbols or shapes, and we have motion, which is animated presentation of frames of data. Motion can actually be very effective, and at the same time, it can quickly become distracting and annoying. Before we get into using color and other visual features to represent data, let's talk about different types of data. We will actually talk about different types of data a few times in this course, so you will see this slide a couple of more times in the remainder of the course. One way of grouping data types is to say there are three types of data: categorical, ordinal, and quantitative. Categorical or nominal data represents things. These things are mutually exclusive labels without any numerical value. For example, continents, people, or drinks. These do not have any numerical values. Ordinal data is similar to categorical data, except that it has a clear order. For example, metals, economical status, month, and employee salary scale. Although ordinal values often have numbers associated with them, the interval between those values is arbitrary. For example, the difference between poor economical status and good economical status might be different than the difference between good economical status and excellent economical status. Or at a company, the difference between pay scale 1 and pay scale 2 might be very different than the difference between pay scale 3 and pay scale 4. Quantitative data means we have numbers. Quantitative or numerical data is data that can be measured and aggregated. For example, weight, cost, discount, and date. It should be noted that date can also be considered ordinal, as one date is bigger than the date before it, so there is a clear order. Okay, let's now go back to the pre-attentive attributes that we use for visualization. Shape is our first pre-attentive attribute. It is easy to see and tell apart different shapes. This could be useful for categorical comparisons, but would not be useful for a quantitative comparison. Orientation is another pre-attentive attribute. Similar to shape, this could be useful to show a categorical comparison or as a directional icon. For example, an arrow pointing up could mean something has increased, and an arrow pointing down could mean something has decreased. Color is kind of the strongest of all the pre-attentive attributes. Color can be effectively used to highlight differences in visualization. When people think about color, they typically mean color hue, which is roughly speaking the color name. For example, color blue versus color red. Primary and secondary colors, meaning yellow, orange, red, violet, blue, and green, are considered hues. And of course, there are many more color hues. But color is more than just the color hue, which is the name of the color. Saturation or intensity is the strength or purity of a color. To achieve a different saturation or intensity, we mix the original color with white to make varying degrees of pastel color. These are called tints. Value or brightness, on the other hand, is the lightness or darkness of a color. To get a different value or brightness, we mix the color with black to make varying degrees of brightness. These are called shades. There are many different color models. RGB, red, green, blue, maps these colors to the corresponding color receptors in the eyes. And we have HSV, which is based on hue, saturation, and value. RGB and HSV are common color models in computer graphics and data visualization. Here is an example of color value being used to draw attention in a visualization. For example, this can represent a higher quantity or something like that. As we explained before, color value is the measurement of the amount of black that a pure hue has been mixed with. By adding black to the color, the value is made darker, resulting in what's referred to as a shade. Color value can be very useful to encode quantitative data. Higher quantitative values are represented by darker colors. A use case is in a sequential color scheme for visualization, which we will learn in the next lecture. Texture is another pre-attentive attribute. It was common to use texture in data visualization when printers only printed in black and white. Tools like Excel and PowerPoint offer texture, and some tools like Tableau don't have it. Just something to keep in the back of your mind, texture is useful to encode categorical data, but not quantitative data. Size can be used to encode both categorical and quantitative data. I should mention that size is not a good visual feature for making precise quantitative comparisons. Notice that it's easy to see that this circle is smaller than others, but it's hard to quantify that amount. Is it 1/3 of the size or 1/4? It's actually neither. Similarly, this circle is easily noticeable, but again, we cannot easily quantify how bigger it is comparing to other circles. I should emphasize that size is highly pre-attentive, meaning it can be perceived almost instantaneously. If you want to show precise quantitative comparisons, position will be a great choice. Also, length or height from a common baseline will be a very good choice. When using position to visualize data, we can see even the smallest differences. For example, in this visualization, we can easily find which circle is positioned further to the right, which is this circle. And with a slight modification, this one is now the one that's furthest to the right, and we can easily find it. Orderliness of symbols or shapes can also be considered a pre-attentive attribute. This chart is ordered alphabetically and shows the number of treatments for different insurance companies. Notice how hard it is to answer these questions quickly and accurately. What is the top provider? What is the bottom provider? What are the top 3 providers? What are the bottom 3 providers? What is the rank of Humana? Now, we order the chart based on the data. Notice that we quickly see that the bars are ordered regardless of what they represent. So, order is a pre-attentive attribute. Now I ask the same questions. What is the top provider? What is the bottom provider? What are the top 3 providers? What are the bottom 3 providers? What rank is Humana? We can answer all these questions much more quickly and more accurately. We had actually discussed in the previous lecture that we should be strategic about our pre-attentive attributes for our visualizations, and we showed sample bar charts. Here in this example, we are portraying orderliness as a pre-attentive attribute, just like color and shape, which can instantaneously be noticed. Now, let's watch a short video about data visualization and pre-attentive attributes, kind of summarizing what we have been talking about. This video is by Column 5 Media, a visual communication company specialized in data visualization and social media.
They say knowledge is power, but how do we make knowledge powerful? Especially when that knowledge comes in the form of data. Lots of data. How do we find the meaning? Tell the story. Share the story. Infographics, where data meets design. What makes good data visualization? Take a few seconds to count the 7s in this number set. How many were there? Not sure? Now try. A simple color change makes comprehension almost instant. Color is one of several pre-attentive attributes, like size, orientation, flicker, visual clues that the human brain processes within 250 milliseconds. Now imagine that we're not looking for specific numbers, but patterns. We can use color to show correlation, size to show quantity, or orientation to show trends. And not just data. The power of design can be used to better communicate all sorts of information. Processes, hierarchy, anatomy, chronology. Better communication through innovation. Because your message is only as good as your ability to share it.
All right. We all have built-in biases. Why is that? Psychologists describe two thinking systems that we use to make sense of the world. We use both top-down and bottom-up processing when we think. We have a system 1, which operates automatically and quickly with little or no effort and no sense of voluntary control. And we have a system 2, which allocates attention to the mental activities that demand it, including complex computations. We can actually compare the pre-attentive stage of our visual perception to system 1 and the focused attentive stage of perception to system 2. System 1 actually feeds system 2, meaning system 1 generates impressions, intuitions, and feelings for system 2. So system 1 can easily make us biased. For example, we see a very crowded and bad-looking visualization and we get mad, and that will affect our main judgment and the analysis of that visualization in the system 2 of our thinking. System 2 can be engaged as needed to solve more complex problems or where system 1 runs into some sort of difficulty. It should be noted that we spend most of our time in system 1 in which we think fast. Only if we encounter something unexpected or if we make conscious effort, we will engage in system 2, where we think slowly with focused attention. Here in this table, I'm putting system 1 in contrast with system 2 for various scenarios. For example, if you're asked, what is 2 plus 2? We use system 1 to answer that. But if you're asked about our phone number, we use system 2 to answer that question. As another example, driving a car on an empty road uses system 1, whereas parking our car in a tight space requires system 2. How about this multiplication? For some people that don't like math, there might be an immediate reaction from system 1 and it stops right there. But for most of us in this course, we get into our calculator mode in system 2. For example, we might take 20 times 23 to get to 460, and then we subtract 23 to get the answer, which is 437. This is in fact our system 2 at work. As we explained, impressions in system 1 affect the conclusions of system 2. So the way that our data is presented will impact the way that we perceive the data. So context matters a lot. Furthermore, mood and emotions influence reasoning processes and critical thinking. Emotions actually impact the depth of information that we gain from a visualization. We always try to simplify our data visualizations, which is good, but we need to be mindful of oversimplification, which can result in distorted understanding of the data. Now, let's wrap up this lecture by giving an example of a strategic usage of pre-attentive attributes. This chart is kind of a failure as we are not strategically using pre-attentive attributes. We are a business whose data is represented by these blue diamonds. And we want to show in what areas we are doing great and in what areas we are not doing so great as compared to our competitors, A through E. Higher index represents better performance and a lower index means lower performance. Looking at this graph, the audience need to do a lot of back and forth between this legend at the bottom and the data in the chart to decipher what's being conveyed. Even if they are very patient and really want to get information out of this visualization, it is nearly impossible because our business's blue diamonds are actually sometimes obscured by other data points, like you see here, and you see here, and you see here. So the audience cannot make some of the comparisons at all. The bottom line is that this visualization is not a good visualization. Now consider this chart, where we were thoughtful about where we want to direct our audience's attention to and accordingly used pre-attentive attributes of color and position to make that visually clear. So now the audience knows exactly where to look and they notice immediately that our business is doing so well in terms of pricing. In fact, we are ahead of all our competitors. Also, the audience easily realizes that in terms of convenience, we are doing well. We are number 2. We are just behind one of our competitors, which is this one, competitor A. And also, the audience easily realizes that we are not doing so great in terms of service and selection. In fact, we are behind all of our competitors and we need to work on that. So in this visualization, we are being strategic about using our pre-attentive attributes and our efforts are paying off. Okay, we will continue our discussion in the next lecture, going over the use of color in data visualization. See you soon.